All right, what I'm going to do first is square both sides to get rid of the square root, changing this equation to x plus 9 is equal to 9. So clearly after subtracting 9 from both sides, I get my solution. No surprise here that x is equal to 0. And as mentioned in class, we should probably plug this in just to see if it is correct or not. So let's see, that would be 0 plus 9. Is that equal to the value 3? Yes, it is. That's the square root of 9 is equal to 3, or 3 is equal to 3. So we'll do this for a couple of examples, but really I'll leave that up to you to check to see if the number is correct. Now if we compare this to question 2, where it's the square root of x plus 9 is equal to negative 3, our strategy is still the same thing if you're trying to guess the answer, and that is to square both sides. On the left you get x plus 9, and on the other side, you get 9 again. The negative cancels if you square it. So your solution, again, is x is equal to 0. However, if you go back to the original equation and put 0 in place of x and ask, is this true? Well, this time the answer is no, because the square root of 9 is 3, and that does not equal negative 3. So this is actually not a solution. We call that an extraneous solution. There are no solutions to the original equation. So for the remaining problems, what I'll do is just say which is the extraneous, which one works, and I'll leave it up to you to check. To solve this equation for x, we have to do an intermediate step here where I subtract 1 from both sides, again taking us to something where we have the square root of 2x plus 5 is equal to 3. Again, my strategy being, okay, I'm going to square both sides of this equation. This time we have 2x plus 5 is equal to 9. If you subtract 5, you get 2x is equal to 4, and if you divide both sides by 2, you get x is equal to 2. And it turns out that this is a solution to the equation. For problem 4, I'm going to start by subtracting 1 from both sides, changing this to negative the square root of 4 minus x is equal to negative 4, being careful when I square both sides to include the negatives. I'm squaring the entire sides. The negative squared is a positive 1. The square root squared is just 4 minus x. And negative 4, if you square it, is equal to positive 16. All right, so continuing, if we have 4 minus x is equal to 16, I guess I could subtract 4 from both sides, which gives me negative x is equal to 12. After dividing both sides by negative 1 would give me x is equal to positive 12. I'm just in my calculator going to check to see if that is in fact a solution. And it definitely works. So you can check this too. And that is it for 4. All right, same strategy where I'm going to add x to both sides. I'm going to choose to write this as the square root of x plus 5 is equal to also x plus 5. Probably you could guess an answer maybe at this point, but again, I'm just going to stick with, all right, I'm going to square both sides. On the left, very simple, you get x plus 5, but we must be careful when squaring a sum or a difference. You get x squared, the first term squared, you get 5 squared, which is 25, the last term squared, but you also get double the product of whatever appears here. The product is 5x, and if I double it, I get 10x. So this changed the root equation to a quadratic equation, and our strategy was to subtract x and 5 from both sides, changing it to something that hopefully can factor. So this is x squared plus 9x plus 20. Where is this equal to 0? By factoring the right side, I get x plus 4 and x plus 5. So it looks like there are two solutions. It looks like the solutions are x is equal to negative 4, as well as x is equal to negative 5. I'm going to plug this in my calculator and see if both work. All right, as it turns out, both of these values are solutions, again, to the original equation, so no extraneous solutions in this problem. All right, this one's set up nicely where we can just start by squaring both sides. The left side squared is just x plus 21, whereas the right side squared is you square the first term, you square the last term, and if you double what you get by taking the product of 1 and x, there's our answer, x squared plus 2x plus 1. Again, this is a quadratic where we're going to take this approach of I'll subtract x, but also 21 from both sides. Changing this equation to 0 is equal to x squared plus x minus 20. This one factors if you do x plus 5 and x minus 4, kind of similar to the previous question, except here we have x is equal to negative 5 and x is equal to a positive 4 instead of a negative 4. So I'll go to my equation to see if this thing worked in the original equation. All right, it turns out that positive 4 is a solution. However, negative 5 is not. I think I will expand on this one here, where if you look at the original equation, since the square root itself can never yield a negative answer, if you were to put negative 5 in place of this x, this side's equal to negative 4, I already know that that can't possibly be a solution because the square root can never yield a negative number. So if you want to take that a little bit further, that is the square root of, you'd put negative 5 into all the x's. On the left, you get the square root of 16 is equal to negative 4, and that is false. This will typically happen when you get a solution that's extraneous. It's just that one side of your equation, it should be like the positive value of the square root instead of the negative. So that's what goes wrong here, and that's it. This problem, again, is set up where you can start by squaring both sides. No problems there. A little more complicated on the left. If you square 2x, that would give you 4x squared. And if you squared 5, you get 25. The middle terms are 2x times 5, which is 10x. But if you double it, that is 20x. And this time it's the right side that's simple, where you just get 4x plus 109. All right, again, we have quadratic. Hopefully this thing factors. I don't know. I'm thinking if we can guess the answers, that would be nice, but I don't know if it's going to be easy to guess. Okay, so here we have 4x squared plus 16x. Plus, no, that's got to be minus. Minus 84. Yeah, equals, right? Yeah. Okay, so does that factor? So we could use the quadratic formula, or we could try to guess some factors of this equation. So I think that 4 actually goes into 16 and 84. I'm going to factor 4 out from this equation. So here, I'm going to remove the greatest common factor, which is 4, essentially dividing both sides of my equation by 4. If I do that, let's see, we have 4x squared divided by 4 is just x squared. 16x divided by 4 is 4x. And if you take 84 and divide that by 4, yeah, you get 21. That's a negative 21. Okay, much easier to think about factoring this. The factors, okay, you want to multiply to a negative 21, add to a positive 4. That is a positive 7 and a negative 3, meaning the possible solutions are negative 7 and positive 3. All right, I'll go to my calculator and see if those work in both equations. It turns out that 3 is good. However, if you put in negative 7, again, it simplifies to one side is going to give you 9 and the other side gives you negative 9. So I know this is an extraneous solution. I don't want to include it, and that is it. For question 8, we have a middle step here where I'm going to add 1 to both sides, changing this to the square root of x plus 421 is equal to x plus 1. Just to recall, you could start by squaring both sides here, but if you square this side, it's not as simple as saying you square the first and the last term. You would have 4 terms to worry about. So that's why we do this middle step here, where get this thing by itself first. All right, now that we've done that, I'll square the left and the right. Okay, the left side's very simple. We just get x plus 421. That's equal to x squared plus 2x plus 1. I will now subtract x and 421 from both sides. Okay, 0 is equal to x squared plus x minus 420. All right, I want to guess the factors of this. Well, one's got to be a positive and a negative. The values should be close to each other if I want to sum to a positive 1. So let's see, 420. Let's see, maybe if I divide by... 420, if you just think about that number itself, is divisible by 20, and the result is 21. So if I happen to put a negative on the 20, the product would be negative 420, yet if I add negative 20 and 21, that would give me a positive 1. Those are exactly the two numbers I would like. That means this is x plus 21 and x minus 20, making the two solutions negative 21 and positive 20. Of course, I just want to check to make sure that both of these are true. All right, so it turned out that this one was good, this negative 1 was bad. But again, going back to the original equation, I would have seen that like after a couple of steps of plugging it in. The right side would be a negative number, and the square root can never equal something that is negative, and that's it for 8. Here we have a question with 2 square roots, and we saw in class that this meant we're probably going to have to square both sides twice through this process. But to start this, I'm actually going to square the left and the right. I'm doing this because, well, the left side simplifies very nicely to x plus 9. It's the right side that's a problem, but we take the same approach when you square a sum of two terms. You square the first term, squaring the square root just gives you x. I square the last term, which is 1. The product of those two things is 1 times the square root of x, or just the square root of x. And if you double that, you get 2 square root of x. So at this point, I still have a square root, but at least one of them is gone, the square root of x plus 9. So I can't combine any like terms, but I do see if I subtract x as well as 1, at least I'm isolating the portion that has a square root of x in it. What this does is change the equation to 8 is equal to 2 times the square root of x. There are two approaches you could take. You could divide both sides by 2. I kind of like that approach. When you do that, you get 4 is equal to the square root of x. To get rid of the square root, I mean, it's kind of trivial for this problem, but you will square both sides. One potential answer, or actually the only answer in this case that could work, is x is equal to 16. But you could also, if you want to try this out, you could square both sides before dividing by 2, and it's worth checking out what that looks like. What that means is, again, we should end up at the same answer of 16. If I square both sides, 8 squared is 64. When you square the 2, you get 4, and when you square root the square root of x, you get x. Here you just would have to divide both sides by 4, and 4 goes into 64 a total of 16 times. So no matter which way you do it, it takes you to the same answer. The last step is just to make sure that this thing is a solution, and it turns out when you plug it in, this works. So you could take either path that you would like. I say if you can nicely divide the number to the other side, go this way, because the values you square are going to be smaller. If the number here, you couldn't divide it to both sides nicely, I would say you'd have to take this approach, and then the simplifying might just be a little bit more difficult towards the end. Again, 2 square roots, both on the same side this time. I'm going to add the square root of x plus 1 to the right side of this equation. This changes to the square root of x plus 10 is equal to 1 plus the square root of x plus 1. This way, you could start this problem by squaring both sides, but the left side would be a disaster. There'd be so many terms that have square roots in it. It's easier this way because if you square the left, it just gives you x plus 10, which is nice. It's the right side that's going to be kind of messy. But if you square the 1, you get 1. If you square the square root of x plus 1, it just gives you x plus 1. And if you double the middle terms, you get 2 the square root of x plus 1. All right, if we combine some like terms, we get x plus 10 is equal to x doesn't combine with anything. We have 1 plus 1, which is 2. And then we have 2 the square root of x plus 1. I can now subtract x from both sides, as well as this 2. I can't do anything with the 2 in front of the square root of x because it's attached by multiplication. I'll have to deal with that later. But here we get 8 on the left side again, and that's equal to 2 times the square root of x plus 1. This is really similar to the previous equation. I'm going to take the approach of dividing both sides by 2. I'm left with the square root of x plus 1 instead of just the square root of x, but who cares? You can square both sides. On the left, you get 4 squared is 16. That is gone. It's just x plus 1. I'm subtracting 1 from both sides. That means the answer is, the possibly extraneous solution here is 15. Does that work in the original equation? And the answer is yes, this is a solution, and that's the only one. All right, this one is, again, nicely set up where I can square the left and right sides. If I square the left side, again, simply it's just x plus 8. On the right, 1 squared is 1. The square root of x plus 3 squared is x plus 3. And if I double the middle terms, hey, what do you know? You get 2 times the square root of x plus 3. I'll combine some like terms. Okay, we get 4. We get an x, but then we also have this 2 the square root of x plus 3. Nice. I'm going to subtract x from both sides as well as 4. This changes it to 4 is equal to 2 the square root of x plus 3. Okay, we didn't get 8 this time. That's nice. If I divide both sides by 2, because I can, I get 2 is equal to the square root of x plus 3. If I were to square both sides, so I'm squaring the left and also the right, I get 4 is equal to just x plus 3. Subtracting 3 from both sides gives me my answer of 1. Is 1 an answer to the original equation? I'm just actually going to look at this one. I think it's simple enough. On the left, you get the square root of 9, which is 3. Okay, on the right side, you get the square root of 4, which is 2. 2 plus 1 is 3. Yep, this one works out, and that is it. All right, again, squaring the left and the right seems to be a good first approach. We get x minus 7 is equal to, all right, if I square the first term, I'm squaring the square root of x minus 14, so I just get x minus 14. If I square the last term, it's just, again, a 1. And then I have twice the product of the two terms, which is 2 times 1 times the square root of x minus 14. I'll combine some like terms. Okay, we get x minus 13 plus 2 the square root of x minus 14. Okay, I'm going to subtract x from both sides. That's nice that it cancels from the equation. And I'm going to add 13. Do that at the same time. Okay, this time we get 6 is equal to 2 times the square root of x minus 14. I can divide both sides by 2. I can square both sides. And then I'm going to add 14 to both sides of this equation, which gives me 23 is equal to x. All right, I plugged that into my calculator, and 23 was in fact a solution, so we're good there. All right, in this one, okay, I have to start by adding, I guess I'll choose x plus 3 under the square root to both sides of the equation, changing this to the square root of x plus 23 is equal to 2 plus the square root of x plus 3. Great. I'm now going to square both sides. On the left, again, we get x plus 23. All right, this is going to be a little bit different this time. If I square the first term, 2 squared is 4. If I square the last term, square root of x plus 3 squared is just x plus 3. But now, the product of the two terms is 2 times the square root of x plus 3. If I double it, that's 4 times the square root of x plus 3. So what's happening here is there's this times this, which puts a 2 here. And if you double that 2, it gives you 4. Anyway, this is what the equation simplifies to. Again, I'll combine some like terms. I get x plus 23 is equal to, all right, I got 4 and 3, which is 7. We again have this x that's left over, and I can't do anything with the square root with the 4 in front of it, so I'll just put it like that. I can now subtract x from both sides as well as 7. Okay, so the x's are gone, and we're left with 16 is equal to 4 times the square root of x plus 3. I can divide that 4 to both sides. That's perfect. If I do, I get 4 is equal to the square root of x plus 3. If I square both sides, I get 16 is equal to x plus 3. Subtracting 3 from both sides gives me an answer of 13. All right, I'll check it in my calculator. All right, checks out. So 13 is the solution. For this problem, I'm not liking the 2 versus the 1 here. I'm noticing that in every equation with 2 square roots, it's always reduced to just the x's canceled. I'm not sure that's going to happen here, but let's check it out. If I square both sides, taking that same approach, we get 2x minus 1 is equal to, the first term squared is 4, the last term squared is x minus 4, and then it's 2 times the square of x minus 4, and so if we double it, again, just like the last problem, it's really 4 times the square of x minus 4. This is what we have. And, of course, combining like terms. Oh, it's a 4 and a minus 4. Those cancel. I'm just left with x plus 4 the square root of x minus 4. But this time, if I subtract x from both sides, the x's do not cancel. It's just x minus 1 is equal to 4 times the square root of x minus 4. And here, I'm not going to divide both sides by 4. If I did, I mean, you can, there's nothing wrong with that. It'll just introduce a fraction, which just might make the computations a little bit more difficult. I'm going to take the approach of squaring both sides next. If I square the left, that's x squared. The negative 1 squared is a positive 1. And if you double the product of the middle terms, oh, no, we don't. That should be a negative. Negative 1 times x is negative x, and if you double it, you get minus 2x. Gotta be careful here a little bit on the right. 4 squared is 16. The square of x minus 4 squared is x minus 4, but those two things are being multiplied together. It's not that 16 is just multiplied to the x. It has to be multiplied to the entire x minus 4, so I'll incorporate some parentheses. All right, great. We now have a quadratic that I want to set equal to 0, meaning I gotta distribute this 16, and then I'll subtract terms to the left side. Hopefully I can factor this equation. X squared minus 2x plus 1 is equal to 16x minus 64. So I'm going to subtract 16x from both sides, as well as add 64, which gives me x squared minus 18x plus 65 is equal to 0. Does this factor? Can I break this up into a product of 2 terms? If I do, it's got to be an x minus and another x minus. All right, so I'm going to think about factors that work here. So I was getting a little impatient with guessing, so I kind of cheated a little bit, where what I did is in place of y1, I entered the equation x squared minus 18x plus 65, and I looked at the graph and just tried to figure out, hey, where's this thing crossing over the x-axis, right? And I saw that it crossed over the axis at a spot I could guess, and that spot was 5. And that must mean that one of the factors is 5. And if you divide 65 by 5, you get 13. So that's the other place where this thing is equal to 0. So just kind of a way to, I guess, maybe kind of cheat a little bit. Like, if you're having trouble factoring this, graph it. All you're really looking for is the places where it's crossing over the x-axis, 5 and 13. If you know those places, I mean, really, you're done at this point. Those are the solutions. But here I just wrote them as factors, right? If 5 is a 0, it's x minus 5, that's a factor. If 13 is a 0, it's x minus 13, that's a factor. You can check that these work out back to this. But anyway, the 2 potential solutions are 5 and 13. Do both work? I'll check it in my calculator. All right, it turns out that both of these are in fact solutions to the equation. For the rest of the homework, I put in some problems that weren't square roots, but we have a cube root, fourth roots, and fifth roots. All these should be really simple to solve. It's going to be very similar to the problems in the previous portion of the assignment. But the goal is like, okay, here I want to cancel a cube root instead of a square root. The way you do that is by raising both sides not to the power of 2, but to the power of 3. It is this number here that tells you how to cancel this expression. So by that I mean, I'm going to cube both sides instead of squaring both sides. Also, in the previous questions, when you have a square root, like you don't write the 2 in here. You can if you would like to. It's not wrong. It's just that square root is so common we don't write it. And if you have a different root, well, then we do place that number in here. Anyway, if you cube the cube root, you're just left with x plus 4, just like when we were dealing with square roots. The only thing you have to look out for is, on the right side, you're cubing 1, you're not squaring it, but actually it turns out it doesn't matter. If you cube 1, 1 times 1 times 1 is 1, and if you subtract 4 from both sides of this equation, you get -3. I think it's worth checking to see if this works, just maybe as a reminder of what does the cube root mean. So, all right, we can try that out. Does this work? The cube root of -3 plus 4, is that the same thing as 1? Well, that's the cube root of +1. Is that equal to 1? And certainly, I mean, the way we define the cube root is, if you cube this number, does it take you back to +1? And the answer is yes. You could also just check this in your calculator if you'd like to. The cube root of that's supposed to be a positive, the cube root of +1 is in fact 1. One final thought. With the types of equations that we're solving in here, you're always going to get an answer. For an odd-powered root, you're never going to have an extraneous solution. And the reason is, you can take the cube root of a negative number. There's nothing wrong there. So let's actually check that out in problem 16, where solve the cube root of x plus 4 is equal to -1. So this is different. With the square root, there would be no solution. But for this problem, there is a solution. If I start by cubing both sides, on the left you get x plus 4. But on the right, if you cube -1, it actually gives you a negative back. This is why negative values are okay in odd-powered roots. Anyway, if you subtract 4 from both sides, you get x is equal to -5. And let's check to see if this works. Is the cube root of -5 plus 4 equal to -1? That is the cube root of -1. Is that equal to -1? And the answer is yes. You can take the cube root of a negative number. That would give you -1 does in fact equal -1. So in the previous question, -3 was the solution. -5 was the solution to problem number 16. Let's continue with this. So for 17, again, focusing on another cube root. I mean, it kind of looks like this might be a more complicated equation, but I don't really think that's going to be the case. Again, I have the cube root of 2x plus 7 minus 4 is equal to -2. Just like before, the approach is going to be get the cube root by itself. The cube root of 2x plus 7 is going to be equal to +2. If I now cube both sides, if you cube 2, gotta be careful here, it's going to give you 2 times 2 times 2. That's 8. And on the left side, we have 2x plus 7. I will now subtract 7 from both sides and divide both sides by 2. And it is 1/2. X equals 1/2. That is the solution to this equation. Okay, here we have a fourth root instead of a cube root. Here, if you have an even root, just like a square root, you'd have to be careful with the negative values showing up on one side of your equation. Doesn't happen here, but I'm going to solve this by raising both sides to the power of 4. On the left, again, it cancels the fourth root to give us x plus 4. But now on the right side, okay, 2 to the 4th power is 16. If I subtract 4 from both sides, I get my answer, which is 12, and I'll leave that to you to check to see that it's true. Now, if we compare this to, again, really similar here, in 19, the 4th root of x plus 4 is equal to -2. Okay, I know there's going to be no solution to this equation, but to see what goes wrong, I will raise both sides to the power of 4. And yeah, the thing that goes wrong is, on the right, a 4th power cancels the negative, but it still gives you 16. And when you subtract 4 from both sides, it looks like the answer is 12. However, if you take 12 and you plug it into this expression, hoping that it's equal to -2, it's not going to work. You get the fourth root of 16. Is that equal to -2? No, the fourth root of 16 is +2, yet the other side's -2. That's no good. This is an extraneous solution. In fact, there is no solution to this equation. And that brings us to our last problem, question 20. The fifth root of 1 minus 5x is equal to -1. You probably guessed it, that my first step is going to be to raise both sides to the power of 5. On the left, I'm left with 1 minus 5x. On the right, I get -1. If I subtract 1 from both sides, I get -5x is equal to -2. And dividing both sides by -5 gives me x is equal to 2/5. We have an odd root. I'm not worried about this being a solution. You can check that it works. But this is the solution to the equation.